In this video, we are going to learn how to use Wilcoxon sign rank test to test for median. So the first I want to write down the assumptions. Assumptions going to be first one is data paired. So you have paired data. Then the second one is difference is not normal. Okay. So when you take the difference between mean, they are not going to be normal. So that's the assumption. Then the third one actually is the difference, distribution of differences is symmetric around median. Not mean, but median. Okay, that's another assumption we are making. So after you have all these assumptions, let's see how you are going to use this test to test whether median is equal or not, or whether it's more than or whether it's less than for some given value. So so let's write down my hypothesis. So H naught, that's going to be the median, is equal. So if you read the problem, can we conclude that median length of pygmy sunfish differs significantly from 3.7 centimeters? So I want to say median is it's different from median 3.7. So my HA is going to be median is not equal to 3.7. Okay. So now once you have this, you can decide alpha. Let's say alpha is 0.05, which is very popular. Now let's write down the values. So I have these data values. So I have 5, 3.9, 5.2, 5.5, 2.8, 6.1, 6.4, and 2.6, and I have two more values, 1.7 and 4.3. Okay. So now we want to subtract 3.7 from this, each one of these. So it's like 3.7 is paired with each of these data points. So I have 3.7 here. So now I can calculate the difference. So I take the 5 minus 3.7 and let's calculate the difference. And that's going to give me 1.3. And when I do the next one, I'll get 0.2, 1.5, 1.8, 0.9, negative 0.9, 2.4, 2.7, and negative 1.1, negative 2, and 0.6. Okay, so I have this. So now what I do, I take the absolute values of these differences. So because some of these differences are negative, so I take the absolute value. Okay, so I have 1.3, 0.2, 1.5, 1.8, 0.9, 2.4, 2.7, 1.1, 2, 6. Now if you are wondering about where what are the steps, so please go to this slide and read the it's contain all the necessary steps. Okay, so now once I have the absolute values, I'm going to rank those values. So now I'm going to give the rank. Okay. So when which one is the smallest? So it's look like this is smallest. So it's like the 1. Then the next smallest one is look like this one. So that's 2. Then next one is here 3. So I can write down all the ranks. Next one is this one 4, and then next one is here 5, and then this one is 6, this one is 7, and this one is 8, this one is 9, last one is 10. Okay. So once you have rank, you have to calculate two quantities. One is called T minus and the other one is T plus. So this is T minus is rank of sum of negative ranks. So this is sum of negative ranks. So which one, what are the negative ranks? So this one is negative value. So then its rank is negative rank 3. This one is negative value. So its rank is negative. This one is negative value. So its rank is negative. So if I add these numbers, then I get the sum of negative ranks. So my negative sum of negative rank is going to be 3 plus 4 plus 8, which is 15. And I can add the positive ranks. And this is going to be, so these values, before you take the absolute value, these values, these are positive. So the rank associated with that, those are the positive ranks. So you have 1 plus 6 plus 7 plus 9 plus 10 plus 2. That's going to be what? 12 plus 6, 18 plus 7, 25, 35. Did I do something wrong? 1 plus, did I miss one? Oh, I missed 5. I had to add another 5. Yeah, so it should be 40. Okay. So that's the rank. So then you calculate the test statistic. So what is the test statistic? If you read the slide, it says test statistic is going to be minimum of these two quantities, T minus, T plus. So that is minimum of 15 and 40. That's going to be 15. 15 is the smaller number. Okay. Okay, so now you have test statistic. Now this one is not associated with any kind of distribution. So how do you calculate the critical values? So you have to use your tables, the tables provided with textbook. So in that, if you take the tables, here is the table. So we have to, first we need the sample size. So what is the sample size? N equal what? We have 10. And the next is it left tail, right tail, two tail? It's basically two tail test. So from here you can say it's two tail. Okay. So let's go back and get the tables. So in here, so N is 10, and then two tail, and my alpha is 0.05. So I am in here, okay, in this row. So my critical value is 8. That's my critical value, 8. Okay. So critical value is 8. Now how do we know whether we are going to reject or fail to reject? So the if you read the slide again, if the test statistic is less than or equal to the value given in table, then you reject H0. Otherwise you fail to reject. So let's write down that. If test statistic is less than critical value we reject H0. Now this is regardless the the type of the test. Is it two tail, one tail? Regardless of that, if test statistic is less than critical value given by this table, we reject H0. So your test statistic is 15 and it's not less than 8. So we fail to reject H0. Okay, so we cannot reject H0. Now in the next video we will use a normal approximation, and we will see how to use normal distribution to get the same conclusion.